So this is the breadboard piece of it. So as you can see, all right, we'll zoom in a little closer. This is our counter. All right, so the left-hand LED is the most significant bit. The right-hand LED that you see in here tied to your breadboard companion is the LSB. So 00, 001. Notice how it's counting through 100, 101, 110, 111. Starts over 000, 001, 010, 011, 100, 101, 110, and 111. So we're constantly going 0, 1, 2, 3, 4, 5, 6, 7. Okay, I'm a little out of sync. Sorry about that one on that one. But we're using our breadboard companion, okay, and the logic chips that we see on here, those are the same logic chips that we have on the board here, as far as you know, how we're using it. So these are the 74 LS74, so we're using our D flip-flops just to do a basic counter here. So that's what we have up here on the board that we just kind of walked through that you can see. So that's how to breadboard everything up and understanding the LSB, the MSB, all right, and how it actually kind of reverses out on the right hand side. Since the last one out, right, that's the slowest one out, this is the divide by 2 flip-flop and how we wire this up. So you're gonna be doing this circuit on your breadboard and wiring it up so that you can do a basic counter, just counting from 0 to 7. Okay, so just once again, you're gonna take a look at this, and you can see that it counts through. So you're going to wire this back to your breadboard companion and use the onboard LEDs to show me that this works. So you can breadboard this up in groups. Okay. One thing that I also want you to make sure that you're paying attention to when you're breadboarding, okay, is understanding the data sheet, okay, and how this applies to the specific pins that we're talking to on here. Okay, I will try to get my shadow out of the way. All right, but understanding when we're looking at the chip, okay, half moon up, clear, preset, all go to VCC. Okay, so they're going to go to 5 volts. Ground obviously goes to ground. And then notice this is one flip-flop on one side of the chip. This is another flip-flop on the other side of the chip over here. Okay, so this is another flip-flop that you can wire. So there's 2 flip-flops on one chip. Make sure pin 14 goes to VCC. So I used 2 chips. I used this as, you know, my A and my B, and then my last one was my C, or vice versa, sorry. This one was my C and my B because I sent the first clock signal in here, and then my last one that was a standalone was my A signal, my most significant bit. So once again, this clear and this preset all get wired back to 5 volts as well. So when you guys breadboard this, always do your power and ground first, and then do your presets and clear back to VCC. All right, your D and Q bar are here, all right, as well as here. So when you do that, your Q bar has to go back into D on each one of these. I would do that step next, all right, and then you have to have your Q signal. Okay, that's what goes back to your LED. So this Q signal would go back to your LED 1. This Q signal right here would go back to LED 2. All right, and then your last one on your other flip-flop will go back to LED 3. Then remember, it drives the clock. So this output has to wire over to this guy's clock. Okay, so you're gonna go from this pin 6 over to pin 11 here. The first clock in comes from your breadboard companion clock. So that's the one you're gonna wire in, and then the future clocks are all wired since we are counting up by Q bar. Okay, after this, you're gonna have to figure out how to count down. So using the data sheet, all right, to breadboard this circuit, okay, this sequential logic circuit that we have over here, okay, as it goes, all right, we're just counting from 000 up to 111 and then doing it over again. So remember, this is a divide by 2 circuit. So each time we're going to divide by 2. And how are we doing that? Because this Q bar is this one's clock. This Q bar is this one's clock. That's how we're dividing by 2. There's only one original clock signal that's coming in, okay, and that's coming from your breadboard companion, okay? So once again, being able to use the data sheet, being able to read over here and interpret the flip-flops, and then being able to actually program, or not program, but breadboard up your breadboard companion to produce the actual counter. Okay, this will be important later on. You're going to need this on your date of birth project when I have it do your date automatically. So when you breadboard this one, you need to make sure that you understand how it works, because you will have to breadboard it again when we do your date of birth and make your date of birth automated. And the first time through, we'll use your switches. Second time through, this is how we're going to automate your system, and it's going to count through the cycle, and that's what will trigger your 7-segment display. But that's for a future lesson, but that's what we're going to get on. So this is doing some sequential logic breadboarding for us. Make sure you have your breadboarding, all your wiring as flat as possible, easy to troubleshoot. Also remember, one last tip for breadboarding. When you breadboard these, make sure each one works as you go through it. So when you breadboard up one side of the flip-flop, test it on the LED, make sure that it's working. Then do the other flip-flop and test them both at the same time, and then do the last flip-flop and test all 3 together. If you do that, it will make your troubleshooting easier. So don't try to breadboard the entire circuit first, and then if something's not working, all right, it makes it harder to troubleshoot. So do one at a time, and I will guide you through that in class. All right, guys, have a good day.